Number 3, for f of x is equal to sine x plus 2 on the interval 0 to 2 pi, determine the intervals where f of x is concave up and the points of inflection and justify. So again, we're going to have to take our derivative. So my first derivative is going to be equal to cosine x. My second derivative is going to be equal to negative sine x. And again, we're going to be setting that equal to 0. And so where negative sine x is equal to 0 is going to be at x is equal to 0 and pi. And from there, we'll be able to set up our sine chart. In this case, I'm not going to put the arrows. I'm going to go from 0 to 2 pi because since sine just kind of is periodic, and so it's going to cycle through all the different values again. I'm only concerned about the x values between 0 and 2 pi, so I don't care about keep on going on and on forever. And then so I have 0 already, and then I have pi, and then I'm going to be listing my factors, which is I only have one factor. It's negative sine x. So if I pick a value between 0 and pi, so let's pick, I don't know, pi over 2. Okay, so sine of pi over 2 is going to be 1. Well, I have a negative in front, so that makes it's going to be negative. So now I'm going to pick a value between pi and 2 pi, let's say 3 pi over 2. Well, that means sine of 3 pi over 2 is negative 1, so that means negative sine of 3 pi over 2 is going to become positive 1. So I have negative positive, so that means my function is concave down and then concave up. Okay, so it wants me to find intervals where my function is concave up. And they want me to justify. So on the AP exam, this is what you're going to have to write. So f of x, so we're going to answer the question, is concave up on the interval from pi to 2 pi. Because, and so here's our justify. So what we used was the sine chart. We used the idea that f double prime was positive, and so that's going to be part of my justification, because f double prime, or the second derivative, is positive. Okay, so that's the first part. The next one, they want me to identify the points of inflection. And so since 0, even though it's showing up as a potential point of inflection, we never had any sign change. You know, there's nothing over here. My graph did not extend, and we did not show any type of concave up or concave down. I didn't show any type of sign change. And so I can't pick 0 as a point of inflection because there's nothing occurring over here. You know, it only starts off negative, so as far as I know, it could keep on going negative. I know that it doesn't, but it's possible with other types of functions. So the only sign change that I see occurs at pi. I'm going from negative to positive, and so I can identify that my point of inflection is going to be at pi. So f of x has a point of inflection. You can abbreviate that by POI, point of inflection, at x is equal to pi, because my second derivative changes signs. So you can, for a point of inflection, you actually can write changes signs. You can't do that for extrema. They want you to be a little bit more specific. But if you want to go ahead and write changes from negative to positive, that is also acceptable. Finally, number 4, determine the intervals where g of x is equal to the cube root of the quantity 2x minus 1 is concave down and concave up. State the points of inflection. So I'm going to be kind of putting everything together on this one. So I need to find my first derivative. So g of x, I need to fix it first, is equal to 2x minus 1 to the 1/3. Well, that means that g prime is 1/3 if you use a chain rule. So 2x minus 1 raised to the negative 2/3 times the derivative of the inside, which is 2. Well, that's just 2/3. So I'm going to multiply 1/3 times 2 times 2x minus 1 raised to the negative 2/3. So there's my first derivative. My second derivative is going to be 2/3, that's my coefficient from before, times negative 2/3 raised to the negative 2/3 minus 1 will be negative 5/3. Again, times the derivative of my inside, which is going to be 2. So I have negative 2, or 2 times negative 2 times a positive 2. That gives me a negative 8 over 9 times 2x minus 1 raised to the negative 5/3. Well, that's just going to be negative 8 all over 9 times 2x minus 1 raised to the 5/3. Okay, and so if I was going to set this equal to 0, okay, if I set it to 0, again, 0 is going to be in the numerator, not in the denominator for a root, but there's no way that negative 8 could ever equal 0. That's an impossibility. And so since I have a constant value, or a constant in the numerator, I'm not going to have any type of root like we have been having in the past. However, I can find where I might have a vertical asymptote. And so if I set my denominator equal to 0, so that my f double prime, it does not exist at that value because of the vertical asymptote, that does give me a value. Okay, so that's finding our vertical asymptote. And so that's going to tell me where my second derivative doesn't exist. So I have 9 times 2x minus 1 again to the 5/3. Again, that's my denominator. And so if I divide both sides by 9, I get 2x minus 1 raised to the 5/3 is equal to 0. If I cube it to get rid of the third, again, this will be 2x minus, oops, forgot my 1 in there, raised to the 5th is equal to 0. And then if I take the 5th root, I get 2x minus 1 is equal to 0. So x is equal to 1/2. So there's my potential point of inflection. So the only way I know that for sure is if I draw a number line and do a sign chart. And so I'm going to go ahead and write 1/2. So that's where my derivative, my second derivative, doesn't exist. And now I'm going to need to list my factors. Well, I have a lot of factors here. I'm going to go back to my derivative. So I have a coefficient of negative 8/9, and then my other factor is this crazy guy right here. Okay, I'm actually just going to make sure, I'm going to put him as the denominator version, so you don't have to worry about this negative right here. That part doesn't matter with the sign. So my list of factors, I have negative 8 over 9. And my other factor is 2x minus 1 to the 5/3. Okay, again, that was my denominator. I'm just putting in the denominator form. So negative 8/9 is always going to be negative. So I'll need to, so I'm finished with him. Now I'm going to use, and I don't have to worry about plugging anything for negative 8/9 because I don't have an independent variable to plug into. So now I'm going to deal with a factor of 2x minus 1 raised to the 5/3. If I was going to plug in a value less than 1/2, let's say 0, I get 2 times 0 minus 1 is a negative 1. Negative 1 raised to 5/3 is going to still be negative. It's actually going to be negative 1. If I pick a number greater than 1/2, let's say 1, 2 times 1 minus 1 is going to give me 1 to the 5/3. Again, that's going to give me, instead of a negative number, it's going to be a positive number. And so now I'm going to multiply my sign. So negative times a negative is a positive. A negative times a positive is a negative, so that means my function is concave up from negative infinity to 1/2, and concave down from 1/2 to positive infinity. And my point of inflection is 1/2. So f is concave up from negative infinity to 1/2. F is concave down from 1/2 to infinity. And f has a point of inflection at x equals 1/2. And there we go.